Section 8, atomic spectra. Now we study a demonstration. So we have this light tube. Inside we feel different atoms or molecules. So then we turn on the power. Usually we need a few thousand volt. Then the different atom will give you different color. So now you use this device we call diffraction grating. Then different color going to separate to different angle. Now on the screen we turn off the light. The room is supposed to be dark. Then you're going to see different color come out. Okay, so this hydrogen, different color. Different color means different frequency. Different frequency means different energy. Because energy equals h, the constant, times frequency. So now the mercury will give you different color, different frequency, and then neon also different. What this tell us? Inside the atom, there are different energy. So electrons going to stay on the different energy state, and we call energy shell. That's what we're going to study. So now this one we call absorption spectrum, which you see the dark line on the bright background. For example, if you watch sunlight, well, you need some protection, like wear sunglasses. Okay, you watch sunlight, you find a few lines missing. Why? Because the atoms in atmosphere observe those frequency, so they're missing. So again, we can study atom just by study the spectrum. This we call the emission spectrum, dark background, bright line, and this we call absorptions, dark line on bright background. So the spectrum just like a fingerprint of atoms. We cannot see atom. We cannot see inside the atom. But the different atom give us different color, then different frequency, then different energy. So we can study the structure inside of atom by studying the spectrum. If we come back to a classroom, I will give you a demonstration. But why? So we're going to study section 9. We're going to study very important model called Bohr model. And Bohr's name of scientist, please remember his name. So Bohr was first one explained the spectrum of hydrogen. Remember hydrogen. Okay, so that's 1913, 100 years ago. So now look this model. Okay, Bohr tell us, see the inside this one here is the nucleus, proton, neutrons. But for hydrogen, only one single proton there. Then electron circle, make this kind of circle. You see n equals 1, 2, 3, 4. Okay, that's different energy level. So now, normally, electron going to circle at here, n equals 1, small circle. And this we call the ground state. So now, if you give energy to the atom, electrons receive energy, will jump to higher energy level, to second circle, n equals 2, and n equals 3, or n equals 4. Then electrons has more and more and more energy. Okay, so let's see this. Electron circles nucleus only in certain orbits, called energy state or energy shell. Okay, so now ground state is the first one, n equals 1. Electron circle nucleus with the minimum radius. And Bohr can calculate how far is the electron from nucleus. So now, when the atom receive energy, observe energy, like electricity, electric energy, then electron can jump to higher energy state. N equals 2, 3, 4, we call excited state. First one we call ground state. But those state, excited state, is unstable. Electron cannot stay there for long. What happens? Electron will come back to ground state again. Say from high energy back to low energy. Just happens this energy difference equals energy of the photon. So when electrons go from second one to first one, from third one to first one, or number 4 back to first one, different energy will give you different photon with different color. For example, here's exactly what happens. And here's the ground state. Then electrons receive energy, can go to first exact state, that's n equals 2. Next one, n equals 3, 4, 5, or even higher. Okay, so now those states are unstable. Electron will come back, so energy decrease. Because conservation of energy, that energy give off as a photon. Okay, so when electron from second one, third one, number 4, number 5 back to 1, well, this color you cannot see because they are ultraviolet, higher frequency. But when from high energy back to the second one, we can see the color. You can see the red, green, and other colors. Okay, so electrons go from high energy back to low energy, energy reduce. As the result, you have photon come out with different color. Okay, so that's exactly what happens. Why we see those color from hydrogen. Remember there are trillions of atoms. So that's why even they go up and down randomly, but we can see those color all the time because so many of them. Okay, so that's called Bohr model. We didn't study the theory, the mathematical formulas, but we should remember what's going on, and his name, Bohr, and what is the ground state, excited state, and energy state. Now, it turned out to be Bohr model is too simple. Okay, so it's perfect for hydrogen, but when you study other atoms, different atoms give you different color, the Bohr model is not enough. So then we have modern theory we call quantum mechanics, which is very involved. We're not going to study the detail. Instead, we're going to study a few important conclusions. Okay, here's the modern theory. Electrons is not circle at same distance from nucleus. The electron can be here or there, but the most time, I will say 90% of the time is around this area. Okay, so we call probability cloud. Okay, and motion of electron in an atom is quite complicated. Uh, so if atom has more than one electron, like helium has two, lithium has three, mercury 80. Do you think so many electrons going to stay together? No, they will be separate as far as possible because they all carry negative charge, going to repel each other. So now some electron will go along the S direction, some along the Y direction, some Z direction. Uh, okay, can be even more complicated under magnetic field. Okay, become more complicated. Uh, and also, uh, the electron has the spin, spin, magnetic field. Uh, so sometimes this magnetic field of electron follow magnetic field from outside. Some just go opposite. So different the possibility. So now, if an atom has more than one electrons, the electron is going to have a different behavior. So now, we're going to go back to the classical structure because it's easier to understand. Okay, so now here's the atom. The center is nuclear, proton, neutron stay here. Now here's first circle, first energy state. So if you have only one electron like hydrogen, don't stay right here. The helium, the second electron going to stay here. But now the next one, we have okay lithium. Lithium have three electrons. Now the first two going to stay here. The third one will go second energy shell. Then next one stay here. Next atom, the last electron stay here. Then next one go here. So anyway, so electron will go different energy state. Some stay in the first one up to 2, some stay second one up to 8. So when we study a periodic table, when we study chemistry, we need this to study behavior of the different atom, different elements. You may ask why electrons either stay the first circle, second circle, and not between. Well, it's just like people living in the building. You either live in first floor, second floor, and third floor. You cannot say, no, I want to live 2.5. There's no room over there. Okay, so now from the spectrum, we only measure the energy of the first one, the second one, or third one. We don't see any energy, we don't see any color between. So that's why. So now the conclusion. For atom which has more than one electrons, other than hydrogen. So how we can tell the different electrons in atoms? They have different energy, like this one, that one. They have a different angular momentum, like this one, that one. Also, they can have different behavior in magnetic field. So how we can tell the difference between the electrons in same atom, different electron, how we can tell the difference? We say for atom which has more than one electron, 4 quantum numbers are needed to determine their energy, the motion, and behavior. So remember this conclusion. Every electron has 4 quantum number. Every electron has 4 quantum number. You don't have any 2 electron same quantum number because something must be different. they either have a different energy or they have a different uh, angular momentum, or they have a different behavior in magnetic field. Something must be different. Uh, so just like different students have different ID number and different electrons has different quantum number. Uh, every electron has a quantum number. How many? 4 quantum number. Please remember that. Okay, so these 4 quantum number have a different name. First one called principal number, we use N, which tells the energy. And N can be 1, 2, 3, 4, give you different energy states or different energy shell. The second one called orbital quantum number. Orbital quantum number give you angular momentum. The third one called magnetic quantum number. Okay, the last one called spin number, SPIN. Okay, so remember every electron has 4 quantum number. Okay, every electron has 4 quantum number. Okay, so now inside of an atom energy stays like this. N equals 1, just 1 energy shell. When N equals 2, there are 2 subshells. Some electrons stay here, some stay there. When N equals 3, 3 subshells. When N equals 4, 4 subshells. Okay, so when N increase, there are more room, then more electron can stay. Okay, so that's very important. We're going to continue study this energy shell when we study chemistry. That's chapter 10. Very important. Okay, this detail, okay, when you have time, you can study, but most important, remember the conclusions. Every electron has how many quantum number? Every electron has 4 quantum number. The 4 quantum number will tell you the energy, the angular momentum, the behavior, and the orientation of the electron. Okay, so last section, we're going to study what we call exclusion principle. This scientist named Pauli. He was first one to tell us only one electron can exist in a given quantum state. That means each electron in an atom must have a different set of quantum number. The electron must be different. Something must be different. They either have different energy or different angular momentum, different behavior, different orientation. So you cannot find 2 electrons they have the same quantum number. Just like you cannot find 2 students, same ID number. Okay, so this is the end of chapter 9. Thank you.